So I've been asked to present a couple of things about water supply in human context, but Michael knows me well. I like to be an agent provocateur. So I'm going to speak a little bit about humanitarian aid and emergency water supply, but also a couple of other things. There are some nice illustrations. They're not from me, but from an artist called Noyo. And I like the first one that says that we can't manage what we don't understand. That's, I will try also to put a little bit of humor and poetry in what I'm going to say, because the world is otherwise extremely depressing. I would like to start with the question, does it make sense to take care of drinking water for human beings? So you are a scientist, you like figures. That's all the water on the planet. You probably know that. That's all the water on the planet. That's all the fresh water on the planet. And that's all the fresh water on the surface of the planet. So all the water on the planet is 0.1% of the total volume. I'm a geologist. I'm not a hydrogeologist, because hydrogeologists, they only work with this 0.1% of the planet. The other take care of the 99.9%. Then fresh water is 3% of the total water, and the surface water is 0.3% of fresh water. And the biological water, the water that is used by living organisms on the planet, is 1%. So in fact, when you take care of biological water, you take care of 0.00003% of the total planet. So if being an expert is to know everything on almost nothing, I think I'm a world-class expert, because I deal with a little fraction of these three here down the line. But that's not all. This is the physical view of the world, but the planet is also a living organism. So let's have a look at something else. That's, for me, a fascinating figure that I found a couple of years ago, which shows you a little bit how the living organism, what is the repartition of living organism on the planet. So let's start with the first one. So the biggest part of life on the planet are plants. 90% of the life on the planet are plants. So we always think on diversity, but it's plants. There are theories that since 10,000 years, human beings would have chopped half of the plants on the planet. That's maybe one of the explanations of the ecological crisis we have today. And then you have a lot of other things, viruses, 0.2 gigatons, bacteria, a lot more, and fungi and protists. And then there are some animals. So animals still represent 0.4% of the total biomass, which is really not much. If we look at the animals, again, we discover a couple of interesting things. So there's a lot of insects, arthropods. There's quite a lot of fish. The birds are really not very heavy, as you can see, but it's normal. They could not fly otherwise. But what is more interesting is to see that the human beings are 10 times more than wild mammals today on the planet, and that for each kilogram of human being, there's 1.5 kilogram of livestock. So when we speak about the planet today, we speak about a planet that has been quite changed by the presence of human beings. Now, if we make the calculation again, what human beings represent, if you deal with drinking water, the result is even worse, because you have a couple of more zeros, but you have at least three figures at the end, which makes look very scientific, reasonable. That's what you are doing when you deal with drinking water for human beings. So is it very serious? I'm not sure. But if you don't do it, people die, and that's very serious. So this was my introduction. Well, the first part of the introduction, and then I would like to speak about the ecological crisis. So yes, there would be floodings everywhere. I like the humor of Noyo that shows the people on the springboard of the swimming pool waiting for the rescue, or the guy who knows how to deal with droughts and forests, fire. But I have a question. I mean, a person, and that's clin d'œil to your director, A person with COVID is infected by 100 microgram of virus, and that's 0 point, you see, not so many zero, and 1 to 5% of his weight with COVID. And what I demonstrated before is that, in fact, there's 580,000 times less human beings on the planet than the amount of COVID you had in your body when you got it. And I have a question to ask at this stage. Are we really so more contagious than COVID that we are responsible for everything happening on that planet? It's the time where you can enjoy the silence. I don't ask you to answer the questions. I'm going to ask questions. I'm not sure I will have a lot of answers. Good. So, humanitarian aid. Where are our priorities? What is taking our energy? Where do we try to find solutions? What are the challenges? You have heard about the Ukraine war. This is very close to our hearts, they're very close to our minds, very close in our media. You hear it all the time. In the next years, Switzerland will invest 1.5 million Swiss francs in Ukraine, a big amount of money, a lot of money going there that is not going to be available in other places. For us, the question is how much can we invest in water, sanitation, hygiene? I hope everybody knows what it is, otherwise you know now. There is a lot of crisis in the Middle East. There will be the whole question of what we do in Israel, in the Palestine territories, Lebanon, Syria, Yemen, Jordan. I tried to make a little bit of humor before, because now it's not really nice to have all this list of places where you have crises that are lasting since years, where we don't have many solutions, where we don't know how we are going to solve them. Africa is the same, the whole Sudan crisis with all the neighboring countries affected, Mozambique, the Republic Democratic of Congo, such a rich country which is suffering for such instability, the whole Sahel. We have the problems in Asia, Afghanistan, Bangladesh, Central Asia, Abkhazia. Who knows where Abkhazia is? Yes, please. Yes, between Georgia and Russia. So that's also a place where sometimes it's not very well-known places. Only one person of so many knows where it is, but the conflict is still there. North Korea, and then what we have in America. So the list of crises of high level of intensity, where there are killings, where there's instability, is quite long, and it tends to extend every day. I will be retiring next year. I had the impression 10 years ago that the world was getting better, but now the impression is that every month we have a new crisis, and it's always just one crisis adding to the others. There's not many crises that tend to stop. We are dealing also with water resource management in Afghanistan. They face a problem of less snow in the winter and droughts at the end of the summer. The same situation as in Switzerland. Yemen, Chad, we are going to work on infrastructures. There's all the question of sanitation and fecal sludge management. And then on top of that, you have all the typhoons, the cyclones, the forest fires. I mean, just in the last month, we have had a number of typhoons in Vietnam, forest fires in Bolivia, floodings in Europe. So the natural disasters tend also to increase. All these crises are crises where the Swiss humanitarian aid may react, and very often water supply and basic sanitation services are among the first priorities that we should address. So Michael mentioned it, I'm the proud head of the expert group WASH. So we make missions. This was our footprint in May. So it's already a couple of months ago. At that time, we had 33 missions sent in different countries, in Chad, in Georgia, in Indonesia, and South Sudan, working with secondments to UNHCR. Secondment is when we deploy an expert to support a partner agency. So the United Nations High Commissioner for Refugees, UNICEF, the International Committee of the Red Cross. Michael, kannst du mir ein bisschen Wasser bringen? Entschuldigung. The Federation, WHO, IOM, the Mekong River Commission. And since May, we have deployed more people, some people in Chad, in Vietnam to respond to the typhoon, in Bolivia for the forest fire. In Yemen, we have sent an expert who is dealing with groundwater management. In Kenya, trying to work on climate resilience. So you can see that there is a mix of people that respond to direct crisis and people that are deployed with a longer-term perspective where we try to increase the resilience of the population in front of all these different crises. Everything okay? If you have a question, the best is to interrupt me, because otherwise I'm just going to speak without interruption. We have tools that we can deploy. We can deploy tools when there is an emergency. So we have a number of modules that are ready to be deployed. They are stored in our warehouse in Bern. So the first thing we deploy in principle is a field lab. We should know the water quality that is there. So we're going to measure basic chemical parameters, bacteriology as well, total coliform equally. Then we have disinfection kits. We produce chlorine from the electrolysis of water and salt. We have well cleaning kits that we just deployed to Vietnam, for example. We can provide modules to make water distribution, and we recently developed a mobile water treatment unit. So these are instruments that we can deploy immediately when there is a need, but we also have modules that we can deploy for longer term missions. So the borehole camera, a thing that is extremely useful to know not so much your resource, but the equipment with which you exploit the resource, pressure probes, submersible pumps, excuse me. The fecal sludge field lab is a new project that you can see here. And that's something, that's the first one, the first connection to Eawag. This is something we have been developing closely with Eawag, with Sandek, for the design of the lab, then for the procurement, then it was deployed in Cox's Bazar in Bangladesh, then for the training of the people. And that's an instrument that is very interesting that we are going to deploy in more places now, on which we are going possibly to add 2 sub-kits, the wastewater-based epidemiology kit, and another kit possibly on the antibiotic multi-resistance. We have also recently acquired geophysics instruments, so we can make geophysics. I will show that you after on the example of Goma. And there is a possibility that we develop such a module on isotope hydrogeology. So these are modules that we should be able to deploy with experts so that they can make a scientific assessment and provide basis for better decision-making and for better programming. So to give you an idea of where we have been deploying, the borehole camera, the wash distribution modules, or the places where we have been making training. There's quite a number of places where we have been since 2014, training people to try to give them the capacity to make water analysis themselves. The water analysis, the aim is to identify the best sources for emergency water supply and make sure that we don't poison the people. Well, so that's the part on the presentation of the Swiss Humanitarian. And now I'm going to come to a more concrete project, the water supply in Goma. Goma is a city, I'm sorry, I have a cat that I need to drown. Voilà. Goma is a city in the Republic Democratic du Congo. This is a joint venture between ICSC and SDC. So it's a little story, but there has been a decision, well, there has been, how should I start? There has been a meeting between our federal councillor and the president of ICSC, and they discussed about many important things, but they also said that they needed to make a Nexus project. A Nexus project is a project where we would combine a humanitarian aid perspective and a development perspective. Humanitarian aid is often considered as a very fast response, and development has a more long-term perspective, is more sustainable, and we would like to bring more sustainability in humanitarian aid, but we probably would like also to bring a little bit more speed in development projects because they take a long time. So they decided that we should go for a project like that. So directors met, they decided that we have to do a project in Goma, and then we had a look at this possibility to make a project in Goma. So that's Goma, that's the Lake Kivu, and that's the situation how it was at the beginning, with 3 pumping stations that take the water from the Lake Kivu, from where the water is pumped up in different reservoirs, and then from this reservoir, the water flows by gravity again to be distributed in the whole city. So the idea at the beginning was to develop the pumping stations and to work on the treatment of the water. We'll come back on that later. But this is the idea how it was. So why did we decide as Humanitarian Aid to invest in such a massive program? Because we know quite well where cholera is starting every year. And in fact, well, I'm not sure if we use this one. This brown thing is the east of Congo. And that's where almost every year cholera crisis start again, and it's around this Lake Kivu. So that's a place from where cholera starts every year. So if we would be able to improve the water supply in a city of 1 million people, we may be able to have an impact on the spreading of cholera because we try to treat the source of the problem. So that's a good reason to go there. So that's the justification why we do humanitarian aid there. But then when we decide to do something and it's humanitarian aid, it doesn't mean that we are going to do it just quick and dirty. We need to do it in a proper manner. And the approach we have done there is that we have put technical inputs from our experts in the hydrogeological exploration, in the geophysical study, so that's the very logical way, defining a conceptual model, then design a drilling campaign, negotiating with drilling company, then remote monitoring during the exploration drilling, and then establish a scientific collaboration. So to do that, we have sent SDC experts. One of them is Mario Schirmer, because Mario is member of the Swiss Humanitarian Unit. He's also a teacher here. He's teaching hydrogeology, so he has been contributing to that project for the hydrogeological exploration and to design the geophysical study. So in which context are we? So what you see near Congo, this is a volcano. And then you have the land going down, and then you have a lake, and there's water flowing there. What is very interesting in that region is that you have almost 3 meters of water per year, and there's not 1 meter of stream anywhere. So all the water is just going down and then flowing somewhere, and the only place where it can be flowing is the lake. So all this water is flowing, and that's the blue arrows, it's flowing in the lake. So Eawag, a group of people from Eawag, has been studying that. This was not related to our project. This was a long time ago. And they have been looking, they have taken samples from different places, and they have identified that there were different sources of water, but also that you cannot explain the balance, the chemical balance of the Lake Kivu without having a massive inflow of water coming every year. So that's what they have discovered. And they have discovered also that by taking some of the samples, the 2 pilot points on the top, KS7 and KS8, this is something, no? Zoom? Okay, so it's not me. No, okay. So the 2 points, KS7 and KS8, are 2 places where there was an indication that there would be cooler water flowing in the lake, and this could be the outflow of all this water flowing from the volcano. So this is a very interesting target for us to try to find the water, because if we look at the water from the lake, it has a pH of 8.5. It has a very high alkalinity. There's a lot of scaling in the pipes, and you need to change the pipes every 10 years, or you have to make a treatment that is extremely expensive. So we were thinking this is not really the way to find water for a city of 1 million people. We should try to find something else. And in the literature, we found that there's evidence that there would be a massive flow of water that nobody has never tried to exploit. So we thought, okay, let's try to exploit this. This is the model that Eawag has been doing. And this, at 100 to 200 meters, we have water samples that indicate it's fresh water. And then I like this story also. So that's different places in the city. The volcano is up there. And then they were supposed here, A and B, these are two places where these sources were supposed to be. So that's what you have. On the literature, Eawag is telling you there are sources there. So then you can spend your Sunday afternoon and make a satellite imagery, take the thermal band, and try to see if you find an evidence that there would be a flow of water coming in the lake. If you go in the thermal band, you should find it because it's going to be cooler at that place. The surface water will be hot because of the sun, and the water for cooling coming from down should be cooler, and you should find it. And that's what you have with the red arrow and the circle. This is the golden pixel. So when I found that, I decided I believe Eawag, and we go for it. We invested now 2 million Swiss francs in trying to find out if this water is really there, and that's why I call it a golden pixel. That's a very expensive pixel when you have it on your screen because it has consequences. So there seems to be a wet flow. It's flowing from the volcano going down to the lake. And there must be a valley somewhere where this water is concentrating. So this was our hypothesis. So then we decided to make geophysics perpendicular to that valley to see if we can find something. So what is geophysics? Geophysics is a method where you have here we use two different methods. The aim of geophysics is to have a 2D image of what is happening under the ground. So you would like to know what kind of rock you have, if it's wet, if it's not wet, and all of that. So you can use the system of seismic. So you have a weight, you let it fall down, and you measure the propagation of the sound. Then you have all this interference, and you can analyze it. Or you can do the same with resistivity. You have a battery. You put electrodes every 5 meters, and then you put current at different places, and you measure the resistivity, and it will tell you how it is. So that's what you have been doing here. The first line was the very long line, and then 1 and 2 is the places where we found the limits of this valley. So we wanted to confirm it. There was a second little line that was done to confirm if we could find it. And that's the place where we said, okay, let's go there for drilling. So that's the raw image before it's interpreted. So it's very nice, plenty of grays and lines like that. And then a geophysicist comes and tells you, I'm going to interpret it. And when he interprets it, you understand a little bit better what is there. And the geophysicist tells you the dark blue spot there is the target where we should drill. So then you have a hypothesis, a conceptual model, hypothesis, you have a geophysical measurement, you have a target, so you can go and start negotiating to try to find a drilling rig. So that's what we did. It took us quite a bit of time. It's very expensive. We wanted to have a big borehole because we expect to have yields of 100 to 200 cubic meters per hour, which is a lot of water. So you cannot exploit that with a small borehole. So you need to go for a big one. You have to negotiate it. You have to mobilize it. Took a lot of time. But eventually, it was there. So the drilling rig is here. That's the organization of the site. You take a sample every meter to have an idea where you are. And in August last year, I was there, and we were at 192 meters. and we started betting where we would find the water. So in July this year, so a year later, almost a year later, they eventually started to drill again. In the meantime, they have broken the machine, there were elections, somebody was abducted, there was a complaint from the driller that the money was not sufficient, there has been negotiation, they had new security concerns, everybody was freaking out, and I was telling him, but there's a golden pixel, so calm down and everything will be okay. So eventually, we found some water at 208 meters and then drilled further down. We're at 250 meters and now we have 100 cubic meters per hour, which is not bad. We are not able to drill more because the compressor is not strong enough. We will equip and now make a pumping test and to see if everything is okay. So the golden pixel was not completely false. The water is there. The quantity is not bad. We have a little bit too much fluor. I will bother now Michael Berg to find a solution to treat 100 cubic meters per hour to try to take this fluor out to avoid that people have bad teeth. Voilà. So that's where we are. I invited you for this, I think, speech by saying, did we find water? Now we have the answer. Now there will be conclusions and some more nasty questions. So the conclusion, what we need to do now that we have found the water, I think the most important, if we speak about sustainability, is that we must put protection parameters. We have very good quality of water. There's no nitrogen, there's no pollution, there's probably no bacteria. So we have found clean water. Now we need to make a big protection parameters and avoid that people settle down in the catchment area and that we have a degradation of the water. The second thing is that we are going to provide a lot of water to the people. If we don't start investing in sanitation now, we will have big public health problems. So it's nice to find water, but you create a problem. So that's something for the group of Linda. Then we need to put disaster risk measures in place as well. It's a place where you have a volcano and some wells. Well, we have to protect them against the possible lava flow. The flow is flowing, the lava is flowing extremely slowly, but still you have to protect it. And then, of course, it would be good to digitalize the water sector and putting at least a skeleton of a telemetry system, because time are gone where we were just installing hand pumps in Africa. Today, we try to make some more modern installations. I will now conclude by asking questions, because I'm an old, white, fat man, rich. I'm straight, as it's called today, so you are not supposed to have an opinion on anything, but you can still ask questions. So I'm going to ask you some questions. I suggest you listen to them and you observe what they provoke in you. You don't have to answer, but just... So, this image, of course, is a provocation. That's I told you, agent provocateur. But isn't historic digitalization a frontal attack to mental health as well? That's what we submit every day. Would recycling humanity inside the water cycle help reduce tensions between our wishes and the capacities of environment? We care for ourselves, for our relatives, for our immediate neighborhood. Shouldn't we care as well for the water continuously flowing through us? With whom should I partner to try and actively contribute to a rehabilitated water cycle management? Which tools could help me to do that? That's questions. You are a researcher. You are a research institute, so you don't want answers. You want research questions. Providing you some here. I think there's a basic misconception, and it's that environment and the water cycle would be two different things. I think it's exactly the same. The water cycle and the environment is in fact the same concept. This is a very holistic vision of the water cycle. It's been developed by the Japanese government. They have an executive board with all the ministers of the government, and they have to decide how they best manage the water cycle. I think it's a very progressive view of management of the water cycle. But does it make sense to separate ecosystems and water cycle when most of the living part of an ecosystem is water? Isn't that a little bit an artificial separation to think that you have water on one side and the ecosystems on the other? Food production accounts for 70% of the water used by human beings. Is the water simply the first food of humans? Why do we all speak about food and not about water as a food? How often is water condensing and re-evaporating in a city before the wind takes it away? I mean, the water falls, evaporates and disappears. That's really a simplistic view, no? It's fog and it's going up and down, and we never think on that because it's too complex to put it in our computers, maybe. Would planting edges increase the resistance time of water in the city between rains and flying away? Now, I have a question on the rainwater. Rainwater is fairly pure. What should be its preferred use? Actively activating small turbines in the cellar of each house to produce electricity? Or natural ecosystem restoration? Or nothing of all of that because you prefer hearing rain fall on the roof? When rain falls in the city, should we store large amount of water to later cool down the streets when there will be a heat wave? And who should store this water? Each family? Each neighborhood? The municipality? The state? And what does it change to make it happen? The second misconception is that humanity and water would be two. In our guidelines on water of the Federal Department of Foreign Affairs, our minister started the foreword by saying, "We are water." I think it's a very interesting statement. That's what we are. Well, that's what you are. I mean, I cannot pretend that I have only 16% of fat. This would be absolutely lie. That's not true. But still, it's interesting to make a link between us as human beings and water. I mean, first of all, we grew up, we were born, we were created in an amniotic fluid. It was a watery world. And our skin separates an internal watery world from an external world that is not full of water, but where daily there are immense volumes of water that are flowing in this external world. So the question is, shouldn't we call ourselves intelligent water instead of human beings? And if we do so, what would it change to our relation to our environment? Would it help us to better find our genuine place in it, if we would call ourselves intelligent water? So then this gives an idea of the definition of what intelligence could be. Is intelligence the capacity to understand the water cycle to which we belong? This should speak to you, no? As Eawag, as a water institution, intelligence is the capacity to understand the water cycle. Should all be proud, no? But then, if you think we should not call ourselves intelligent water, is it because human beings would not be intelligent? And if you make this statement, which personality trait do you use? Or should we call ourselves a local water cycle? It's almost finished, huh? Yeah, 2 minutes left. It's the last slide. I like these pictures as well. I think there's a lot of hysteria, climate panic, threats, aggression. People try to convince you that the best we can do to be in a safe world is to invest in more weapons, which of course is pure madness. Here also I have a couple of questions. Does climate change hysteria paralyze us with fear? Or does climate change threat energize us to act? And where does fear come from? And where does courage to subdue fear come from? Isn't it coming from the same heart beating in our chest? To reach peace of mind, shouldn't we stop considering a changing environment as a threat? In fact, it's wonderful. As long as it keeps changing, it means that we're not dead. Isn't the sentence, the world keeps changing, the most encouraging paradox we live in? Voilà. So now you write down the answers and send me an email tomorrow, and I will be very happy to have an answer of all these questions. Thank you.